It's times this whole thing. Remember, we multiply our rates together. That's the chain rule. Now, there. Now, can you see it better? Okay, ready? You just take your answer. You do the outside one, and then take your answer for taking the derivative of this, because we did that in 3. And it's times that whole thing. So yes, you have to have parentheses. Okay, are we ready? You do, because of the 5. If I didn't have the 5, you're right. I wouldn't. Well, yeah, it's still. It's all multiplication, but. Okay, you should have 3, 7 out. I'm sorry, I don't know what color it is. That's out of a different book. So we're going on. Today we're going to do 3, 7. Tomorrow, reteach it. For those of you who don't get it. And I'll be here in the morning. Then Wednesday, we still are working on 3, 7. So we have 3 days on this, making sure we understand it. And then on Thursday, you have a very difficult partner quiz on 3, 7. It's hard. We'll see. And then we'll do 3, 8. I forgot what it was. Oh. Now, I put a class opener on here. Looks like that, but it doesn't have, yes, it does have that. Dylan, put your phone away. Because we already did 3, 6. 3, 6 is due today, remember?
What color is it?
White. Now, to do this problem, I don't like the way it's written. I'm going to rewrite it 3 times the sine of x to the 4th minus the cosine of x to the 5th power, because that's really where the 5 goes. Those are the same things. You cannot put, if you wanted to graph this on your calculator, you can't write it as the way it's written on that sheet of paper. The calculator will not know what to do. So you need to be able to see that the sine to the 5th is the sine of all that stuff of the 5th power. So, using the chain rule, and I don't have a lot of space, the derivative is 3 times, oh, yeah, let's do that. We'll do the power rule. So it's 5 times 3, so it's 15, I'll call it y prime. And then it's the sine of x to the 4th minus the cosine of x. So I'm going to change colors. Now, times the derivative.
To the 4th.
Sorry.
To the 4th.
Right, I need my parentheses too. To the 4th times. Thank you. And now we're going to do the derivative of the inside one, which is the derivative of the sine is the cosine of x to the 4th minus cosine of x times, I'm out of space, so I'm just going to wrap it around. I hope that's okay. And then I do the derivative of x to the 4th minus the cosine of x. 4x cubed plus the sine of x. Excellent. You guys remembered that the derivative of the cofunction is negative. It's just the chain rule. Is that okay? Homework should have been similar to that. You guys are behind. We don't have time to be behind. And this lesson's going to be tough. Okay. Now, we have to understand a little vocabulary here. Explicit and implicit. Explicit. When I define a function explicitly, I have solved for y. So you will have y equals. Okay, that's explicitly defined. Implicit is when I don't solve for y. If I have x times y is equal to 1, that's an implicitly defined function. I don't explicitly know what y is. I could solve for y equals 1 over x, right? This is explicit, and this is implicit. You use those arguments with people all the time. You might have implied that you were going over to your friend's house this weekend. And your parents say, well, where were you? And you say, well, you knew I was hanging out with so-and-so. Yeah, but I don't know where you were. And you'll say, well, I was hanging out with so-and-so. Obviously, we're at his house. But you never specifically told your parents you were at that person's house. Oh, does that sound familiar? That's implicit. You imply something. Implying is very dangerous because they have to infer from your implication what you are doing. Instead of explicitly saying, I'm going over to so-and-so's house. Now your parents know where you are. Okay? That's the difference. So in math, implicit, I'm not going to explicitly tell you what y is. I'm just going to leave it. In the beginning, you guys are going to think it's easier to always solve for y and then do a derivative. You're going to find out you can't always do that, and it's not always easier. So let's take a simple function like x times y equals 1, right here. We solve for y equals 1 over x. How do I find the derivative? Well, I have my work right here. Well, it is. Yeah, it's just like the other one on that worksheet. Okay, Cole, I'm going to take the derivative with respect to x of both sides. This is an operator. It's like squaring both sides. It's like square rooting both sides. It's an operator. The operator is not dy dx. I will get dy dx, but it's not the operator. It's ddx. Well, if I take the derivative of y with respect to x, I get dy dx. Call it y prime if you'd like. The operator says find the derivative of y with respect to x. We're lazy. We call it dy dx. But to call it correctly, I should say the derivative of y with respect to x every single time. But everybody knows dy dx means that. That's why we use it. How are you going to do the derivative of 1 over x? What's the easy way? X to the negative 1. By the way, we see this one so often that we actually end up memorizing it. So what's the derivative of that? It's negative 1, x to the what? Negative 2. I don't like negative exponents. So dy dx, I'm going to write it without a negative exponent. It's negative 1 over x squared. Okay, that wasn't too tough. Not tough. It'll be tougher to do it the other way, actually. Okay, is everybody okay with that? This is the explicit derivative. Now I'm going to go over to this one, and let's take the derivative implicitly. I'm going to take the derivative with respect to x. What rule do I have to use? I'll have to use the chain rule, that's right. And I have to use the product. But not everybody sees the chain rule. If you would prefer to see it as this, the derivative of x, with respect to x of x times some function of x, then maybe you see it a little bit easier there. Remember, y equals f of x. I can solve for y in terms of x. So y is a function of x. Okay, ready? It's x times the derivative of the second one. What's the derivative of y with respect to x? I have no idea. We call it dy dx. Is that okay? Plus, then it's y times the derivative of x with respect to x. Now, not everybody's going to write that out, but I'm going to write it out at least once. You see the product rule there now. And what's the derivative of 1? 0. Okay, simplifying that, x times dy dx, the other class preferred to call it y prime. Okay? My problem with y prime is I kind of overlook the primes when I'm simplifying things. It's an easy mistake to make. What is the derivative of x with respect to x? What is the slope of y equals x? Okay, Olivia? Ricardo? Solving for dy dx. I want to solve for this. What do you have to do to both sides? If I had 3x plus y is equal to 0, I want to solve for x, you would do what? Minus y. So guess what? I'm going to do the same thing. This is algebra now. So I'm going to get, and you should be doing this ahead of me, it's x times dy dx, that's a derivative, is equal to minus y. And now what do I do to get dy dx by itself? Divide by x. And some of you are going to be bothered by the fact that you have a y and an x in the problem. It's okay. So dy dx is equal to the opposite of y divided by x. My y looks kind of weird. And then some of you are going to say, but that's not the same answer. Well, what was y equal to? Remember, if you have x times y equals 1, y equals 1 over x, right? So dy dx is equal to the opposite of y, if I want to put everything in terms of x. And do you remember how to get rid of complex fractions? We're not going to divide by reciprocals. We're going to multiply by the least common denominator, which is x, because then things fall out really nicely. What happens to the numerator? These cancel and I get negative 1. In the denominator, I get x squared. Wasn't that the answer I got on this page? Isn't that the same answer? Yes, it is. I just substitute. Now, when you do things implicitly, by the way, you will just leave it that way. Yes? Mm-hmm. If you think about what it is, it's the slope of y equals x, which is 1. You will have x's and y's in your answers. It's okay. Later on in the year, I will give you this, which is what they call a differential equation, and we will try to find the original function. We only have to know a certain type, which is good, because some of the other ones are way more complicated. We are going to skip the next example because it's really hard. We're going to come back to it, but we're going to do it the easier one, which follows that. That one looks hard, doesn't it? By the way, can you solve that equation for y? You can't solve it for y. So I have to do it this hard way. But let me show you why this way, implicitly defined functions, are actually easier. Now, first thing I'm going to do, because you don't know what this graph is, I know it's a hyperbola. Solving for y is tough, so I'm just going to change the problem just a little bit. I'm going to do a circle. I'm going to do x squared plus y squared equals 1. And I think one of the homework problems is very similar to this, if not the same problem. Maybe I have a different radius. It's a circle. Now I'm changing the problem just because I know how to solve for y easier. Let's make it x. It doesn't matter. Hey, Grant, you need to turn the page. And you need to write something down. Okay, can we solve for y in terms of x here? Yeah. So let's first do it that way, isn't it? Which is what I would call the hard way to do it. So x squared plus y squared equals 1. What's y squared equal to? 1 minus x squared. And then what do you do to both sides? Square root it, right? So, well, the right side's okay. The right side is the square root of 1 minus x squared, but the left side is not y. It's what? Well, you're cheating a little bit. It's the absolute value of y. Now, number solve means to find numbers that make the sentence true. I can put two things in there. I can put in the positive root, or I can put in the negative root. They both make it true. So I get two equations. Y is equal to the square root of 1 minus x squared, or y equals minus. That's why you get the plus and minus. If I understand what the square root of y squared is, I don't have to remember it. I understand what it is. Well, just to make our life easy, let's just find the derivative of one of those. This is the upper half of my circle, and this is the lower half of my circle. Oh, the circle's pretty sad, but whatever. Okay, so let's take y equals, let's do the positive one. How am I going to take the derivative of that? Okay, we're going to change this to a rational exponent, so it's 1 minus x squared to the 1/2. And now we can find the derivative with respect to x. The operator is, like a squaring or square rooting, is d dx. It is not dy dx. I will mark it wrong when you may call the operator dy dx, because it's wrong. It says, find the derivative of that. Well, guess what? I don't know what that is. We just leave it dy dx. That's what I'm trying to find anyway. And find the derivative of the left side. And what's the derivative of the right side? Let's use the chain rule. 1/2, 1 minus x squared. Then you have to do the derivative of the inside function.
Times negative 2x.
Okay, 0, because the derivative of 1 is 0, minus 2x, right? That's pretty ugly looking. Let's simplify it. Well, this is just a minus 2x in the numerator. The denominator there is a 2, then the 1/2. What about this one? That's 1 minus x squared in the denominator to the positive 1/2.
Why is that the
1 minus x squared to the negative 1/2 is 1 over 1 minus x squared to the positive 1/2. That's what a negative exponent means. I'm just simplifying it. Ask. I just went 0 minus 2x is minus 2x. So I put, because this is all multiplication, order doesn't matter. I put this one over that one. What's going to happen to the 2's? Cancels out, right? Where did what? Because it's from this 1/2. It's 1/2 times this to the negative 1/2. It's 1/2 times that. It's 2 is in the denominator then. Okay, and I don't like the way that looks either. Let's write it this way. It's minus x over the square root of 1 minus x squared. A little complicated. Not horrible. But let's do this implicitly. This was solving for y explicitly. So let's do this implicitly. X squared plus y squared equals 1. Let's not solve for y. That was hard. Let's take the derivative, just as written. The derivative with respect to x. Almost. No? Almost. What's the derivative of x squared with respect to x? It's 2x. What's the derivative of y squared with respect to y? Well, the derivative of y squared with respect to y is 2y. Then you have to do the chain rule times the derivative of the inside function with respect to x. I know. Let's do this one because that's easy. It's 0 because that's what that means. I'm going to add a page and talk about that. The derivative with respect to x of x squared is 2x. And really, times the derivative of the inside function with respect to x. But do I write that down? Because what's that? It's 1. What's the derivative with respect to x, oh no, y of y squared? That's 2y times the derivative of y with respect to y. When you say the derivative of y squared is 2y, it's with respect to y. What is the derivative of y squared then with respect to x? First you find this. I'll give you an example as well. I know this is where the hard part is because we don't understand what a derivative is with respect to something. That's the problem. First you find the derivative of y squared with respect to what's in there. It's not x, it's y. Times, and then you have to take the derivative of the inside function with respect to x. Now just look for a second, just algebraically, what would happen to the dy's? And wouldn't I get this equals dy squared over dx, wouldn't I? The derivative of y squared with respect to y is 2y. y. Then you have to do the derivative of the inside function. Let me say it a different way. Isn't y equal to f of x? So what is the derivative with respect to x of f of x squared? First, you do the derivative of the outer function with respect to what's in there. That's just y. So it's 2 times f of x to the first power times the derivative of f of x, which is f prime of x, right? But isn't f of x just y?
Oh, I get it.
This is 2y. What's f prime of x? dy dx. We have to understand that with respect to. Remember, I've been talking about that, and I said we don't get it. My daughter taught this at the University of Colorado in Boulder in her calculus class, and she says, Mom, they don't understand implicit differentiation. And I said, I know. I said, because they don't understand what a derivative is with respect to. Let's look at that balloon problem that I talked about a while ago. Here's my balloon. And the volume, we're going to make it a perfect balloon. And if my asthma weren't acting up, it would have been nice to bring one in. Of course, I could have you blow it up. Okay, guys, ready? Okay. Okay. I can talk about, guys, listen, this is important, Ricardo. How the volume changes if I change the radius. So I can find the derivative with respect to the radius. The derivative is a rate of change. If I change the radius, doesn't the volume change? Yes. So I'm going to go ahead and pass that through the operator. Because I can't. I like to do things that make things easier. So I get dv dr, and this is going to take some time for us to get. I think you'll be able to get how to do the problems, but all of a sudden the ahas will come later on, especially when we get into applied calculus. This is 4/3 pi. I picked this because it's a real life problem. And what's the derivative of r cubed, but with respect to r? 3r squared. And you really could do times the derivative of r with respect to r, which is fine, because that's just 1. Now, I could ask you, how does the volume change as time changes? That's a different question. So volume equals 4/3 pi r cubed. If I change time, I'm blowing up the balloon, what happens to the radius? It changes. And if I change the radius, then what happens to the volume? It gets bigger. That's the chain rule. So I want to take the derivative with respect to time. d dt. Pass this right through there, because I can. Okay, so what do I get? Equals 4/3 pi. Now, when you say the derivative of r cubed is 3r squared, that's not with respect to time. That's if I change the radius. How does the cube of the radius change? That's how the volume changes. So it's 3r squared. And then I have to say, well, how did r change if I change time? So I have to do the derivative of the inside function, dr dt. We have to talk about how something changes as something else changes. And I have to chain it. I know it's hard. That would be your answer with a dr dt in it. And in chapter 4, we're going to talk about related rates. This is a rate. That's one thing that will probably totally come together for you. Yes, related rates. They'll say the radius of the balloon is changing at, whatever, 0.3 centimeters per minute. They'll give you that. And this now changes physics, so some of the physics problems are easier because of it. Okay, so going back here. Don't do that. Okay, so when I take the derivative of y squared, but with respect to x, this is the derivative of y squared with respect to y. Then I have to multiply by the derivative of y with respect to x. I want to solve for dy dx. I want to divide by 2 right away because it's easier. We don't have to. But can't you divide by 2 on every single term? We should understand that you can do that. I don't want those 2's in there. And you could do it later. It doesn't matter. Remember, this is all multiplication, no distributive property. So I'm going to get x plus y times dy dx equals 0. And I want dy dx by itself. Algebra. So what do you have to do to both sides? Subtract x. And so y times dy dx equals minus x. And now what do we do? Divide by y. Now, I think that's a lot easier looking answer than the other one. Some of you are going to say, but it's not the same answer. But it is. Because remember what y was? I got to go way back here. What was y equal to? Y was equal to the square root of 1 minus x squared. You do not have to substitute it in. But just to make you guys happy, it's minus x over the square root of 1 minus x squared. By the way, when you see the square root of 1 minus x squared, you need to recognize it's a circle. You use geometry to find areas and stuff. You need to recognize that. Okay, and there it is. That's the answer to it, what I consider the hard way.
Why is y? I don't get it.
Why is y what? What's y? If you have x squared plus y squared equals 1, solve for y. Y is equal to the square root of 1 minus x squared. Okay, now we're going to do a hard problem.
What? That wasn't a hard problem.
Yes.
Compared to the next one, this is not too bad. Doing the derivative here is not hard, right? What's the derivative of x squared? 2x. What's the derivative of y squared? I know we'll get the 2y, but then you have to do times the derivative of the inside one. dy dx equals 0. Algebraically, that was easier to handle than the other one. Well, okay, now we're going to go back and do a hard problem, and then we'll just start number 1. Solve for it, because that's what you want to find. Remember what dy dx is? Find the derivative of y with respect to x. No, I could do it with time. I could even find the derivative with respect to y. You have to read the directions. Okay, let's try that fun one. Now, I'm going to rewrite it so I can show my operator. To me, it's kind of shoved in there. Okay, Grant, you need to do this with me. No, I haven't done anything. I'm just recopying it. Because I'm going to do... Yes, we skipped this one because I said it was harder than the other one. Doesn't it look harder? First off, can you solve for y? How? You know why I can't solve for y? Because I have y squared, which is algebraic, multiplying a trigonometric function. How am I going to separate the y out of there? I can't. I need an upper level calculus to be able to maybe do it. So we're not going to do it. We have to leave it. Your answer will have x's and y's. Okay, what's the operator? I want the derivative with respect to what? X. Hey, Grant? No, you need to do. Because that's what was written. I just recopied the problem. Because I want to find the derivative of y with respect to x. If this had been t, it would have been d dt. So this, d dx, this is the operator. That's a really good question. Can I pass it through the 4? Sure. Okay, you ready? What rule do I have to use on the first one? I will be using the chain rule, but before I do there, no, I don't have division. Can't use high to low. It's a product rule. Okay, so ready? It's y squared times the derivative of the sine of y. Well, that's the derivative of sine of y, when you say it's cosine of y, is with respect to y. Then you have to do the derivative of the inside function. So you have to chain it times the derivative of y with respect to x. It's only the first term in my product. How many? Pardon? No, you have to do the product rule. I'm not done. Not done. No.
Plus.
You have to do product rule. It's the first one times the derivative of the second plus the second one times the derivative of the first. What's the derivative of y squared?
2y.
That's with respect to y, though. Times, and then I have to do the derivative of the inside. These don't match. dy dx. All of that is the product. It's the product rule. It's y squared times sine of y. Now, what they'll give you on the exam is they'll give you something like that, and they'll say, show that, and then they'll give you the answer. And I think if you do enough of these, you can get through that fairly easily, because you know what you're trying to get to at least. Here I don't. Okay? Plus, then I have the derivative of x squared with respect to x. Well, that's 2x. And really, it's times the derivative of the inside function with respect to x. But what is that? Still the chain rule. Think of that, just the derivative of whatever. If that were z, then it would be times dz dx. Just so I'm consistent. Okay, ready? Minus, I'm going to ignore the 4. And now what rule do I have to use? Again, product rule. So it's x times the derivative of y with respect to x, dy dx, plus y times the derivative of x with respect to x, equals, oh, I'm going to get this right, even though I wrote it wrong. I have to take the derivative of the right-hand side. I forgot to do that.
What's the key?
Equals what?
Why is the x dy always right? X be dx only?
I will change it. Equals 0.
Should the x be?
It's the first times the derivative of the second, which is this, plus the second times the derivative of the first. Now, the suggestion was, do we have to write dy dx? No, we can make them primes. My own personal issue is I sometimes miss the primes. So if I make it dy dx, it's a lot easier. Okay, I want to clean that up. I want to simplify some things, and then we'll solve. So I get, and let's change them to primes, because the last class said they wanted that too, so we will. Times y prime. You rather have dy dx? Okay. Then, if you like the y primes, you can look at the video from the other class. So this is dy dx. It just kind of stands out at me when I do dy dx. The primes are more subtle, and it's harder for me to see. Now, I'd like to rearrange the order here. It's 2y times the sine of y times dy dx. This is all algebra now. Well, almost. What's the derivative of x with respect to x? 1. I'm simplifying it. I don't want that dx. What is that? 1. And I'm going to distribute this and hopefully get it right. It's minus 4x dy dx. And then I have to distribute the minus 4 over here. So it's minus 4y. What's the x dx? 1 equals 0. The rest is algebra. What I'm going to do is highlight the dy dx's, and I want to keep all these guys on the left side. Anything multiplied with a dy dx in it. Keep them all over here, because then it'll be easier for you to see what's going to move to the right side. Anything without a dy dx. So what am I going to get rid of? 2x and the 4y, right? So I get y squared cosine of y dy dx. Some of you can do this faster than what I'm doing, and that's great. Minus 4x dy dx. Some of you may see right away what to do with that left side. Equals, pardon? I'm going to subtract it. When I subtract it, I get minus 2x, don't I? When I, right. Okay, we're almost done. How am I going to solve for dy dx?
Divide by dy dx.
No, I want to solve for dy dx.
Oh, you divide.
Okay, what do you mean pull it out? It's called factor. So I'm going to take dy dx, factor it out, and I'm going to highlight the dy dx so I can see them. Because what I factor out, after I factor dy dx, whatever's left there, is what still times everything. I'm undistributing. Yeah, you should be ahead of me. That's great. So I get y squared cosine of y plus 2y sine of y minus 4x. Equals, I prefer to keep my things positive, but you can leave it minus 2x plus 4y. And then, what are we going to do? Divide by that. Because this is times, right? I want to divide by this number. If once you know what x and y are, it's nothing but a number. Now, if I wanted to find a derivative at a point, I would just put the numbers in and then solve for dy dx because it's easier. Now, if you become an engineer, you'll be working with lots and lots of letters, and you'll be doing this sort of thing. But I like this because there's no arithmetic involved. And that's the ugly answer. And you can't do anything more than that. That's what it is. It won't be this complicated on the exam. In fact, maybe I'll bring one in tomorrow.
We have to do our test.
Okay, let's do, we didn't get time in the other class. Let's do,
Example 3.
let's try that and then let's do problem 1. The reason being is this is easier than problem 1. This book likes to start out with hard problems to begin with. I like to copy it over again. That's just me. So it's what operations here between x and y squared? This one's not nearly as bad as the last one we did. So let's take the derivative with respect to y. Because here's the operator. There it is, d dx. If it had been a z, you would have done d dz, and you would have weird looking things in there. Okay, so it's d dx. d dx and d dx. So I have to use, as somebody said, the product rule. So it's x times the derivative of the second one. Chain rule times the derivative of the inside function. That's the hard part right there. Plus, then we leave the second one alone, times the derivative of x with respect to x. I can write it, or can I just write 1? I just write 1? Or I can write dx dx, I don't care. Some of you may need to write the dx dx just because that's what it's going to take you to do it. And then all of a sudden, you'll migrate over. Equals, oh, what's the derivative of x with respect to x? 1. And what's the derivative of 8 with respect to
Wait,
x?
so why don't you have to do that?
I did. This was way easier than the last one. If you could do the last one, you should be able to do this one. Okay, so what do I get? 2xy dy dx, or y prime if you prefer, plus y squared equals 1. And I want to solve for dy dx. So what do you have to do to both sides?
Minus y squared.
Yeah, minus y squared. So I get 2xy dy dx equals 1 minus y squared. And then you would divide by 2xy. And this is what they would do on the exam. Give you a problem like this and say, show that dy dx equals this. Because they're going to use it for something else later on. And they want you to use the correct answer. Because in the first part of the problem, they're testing to see if you know how to do implicit differentiation. But even if you don't, they want you to be able to do the rest of the problem. A different problem. You combine all these concepts together. So if you can't get the answer that they have there, always use their answer. If they say show that, always use what they give you. And that's it. Could I have solved for y? Probably. Yeah, I could have solved for y, but then I would have a square root of something that's just, ugh. I could have made y squared equals x minus 8 over x, then I'd use the quotient rule. That's even worse than the product rule. Should we try problem 1? I don't know if it's assigned. You probably would be able to tell me that better. Unless I go look at my assignment sheet. Oh, you know the assignments are in the back of the original assignment sheet. I thought 1 was kind of hard to start with. Then tomorrow, remember, half hour. Those of you who don't do homework, you're going to be lost tomorrow if you don't try it. Even if you try and you fail, it's okay. I want to find dy dx. So what am I going to take the derivative with respect to? I have to do two product rules. Whoops, forgot the x. Let me give you a chance to try it. So you have to use the product rule there. Everybody just walk around. I know my calculator will do it, but I haven't gotten it figured out yet. That's right. Yeah. I like the right-hand side because what's the right-hand side? 0. Mm-hmm. Yes, I will be here tomorrow morning. I was going to say I'll be here after school. I'll be here for a short while after school. I have to go to the T. X squared. You have to use product rule. So it's x squared times the derivative of y with respect to x plus y times the derivative of x squared with respect to x. You're going to get two terms from this and two terms from that one. So it's four things across there. You have to use the product rule. So it's x squared times the derivative of this one, which is dy dx.
Wait, so is that right for just the first half of the lesson?
Mm-hmm. Plus, and then you have to do the other one. Yeah, that's right. Equals 0.
Oh,
You get it?
Yeah.
It's x squared times the derivative of y with respect to x. There's no y there. It's just the derivative of y with respect to x. The derivative of y with respect to y is first, actually. Yeah, equals 0. Hopefully it's right. So you should get x squared times the derivative of y with respect to x plus, you see why you might want the solutions in front of you when you try this. You don't want to get, I don't want you to get frustrated. Check your line right away. You do a whole, spend 15 minutes with a problem that's wrong, and you're just going to get frustrated. So it's y times the derivative of x squared with respect to x. That's for this one. We'll change colors. Whoops. Plus x times the derivative of y squared, which is 2y, that's with respect to y, times the derivative of y with respect to x. Plus y squared times the derivative of x, which is 1. I like to see the 1 there for myself. That's the other one. So you should have 4 terms. And I like...
2x times dy dx?
Where? Which one? I did x squared times the derivative of y plus y times the derivative of x squared. That's okay, but there's no dy dx.
Well, no, I was saying 2x times dx dx. It's
No, it's 2x times y. Okay. Plus 2xy. I'd just like to clean it up. Okay. The rest of this is algebra. These guys I want to keep over on the left side, and the other ones I want to put on the right side. So it's x squared. Some of you will say, oh, let's factor it right away. Yes, we could. Some of you don't see it. They should, yeah, that's good. That means you understand it. But if you don't practice tonight, by tomorrow you will have forgotten. So you need to practice. So it's minus 2xy minus y squared. Factor out dy dx, right? X squared plus 2xy equals minus 2xy minus y squared
could if you wanted me to take an X out of that one.
Yes, we are. It won't help us any though, will it? I was hoping it would reduce. Sometimes it does. Well, let's prove it. What can you factor? What could you factor out of the numerator? A y, right? Minus 2x minus y. And what can I factor out of the denominator? I see something different. X, and that's what? X plus 2y, right? Oh, I don't see anything. There's not much more you can do. Can't reduce it. Sometimes you can. Sometimes you can. Okay. But no more than a half hour, because if you get frustrated, you won't want to do the problem. Where are you going? It's not time.